The general conviction among most experts is that the speculation of how things came to be stays the major clarification for the early times of the universe. This hypothesis joins the development of stars, planets, and in this way, forward life on those planets, including ourselves. Notwithstanding its odd name, the Big Bang, it offers an illuminating assessment concerning what could have occurred at first. The universe was thick in a short space, more thick than a pinhead, with particles thickly pressed. From this second, a giant effect of matter and energy happened, known as the Big Bang. This event, happening billions of years ago, set up the fanning out of huge history. In any case, insensible information, it has set off creating eccentricities with the assumptions of this hypothesis. At the point when NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever, experts assessed that its insight would affirm the hypothesis of the universe's origin. Sadly, after only 1 year in space, the telescope stunned experts with its ability to peer so deeply into the universe's past. The James Webb Telescope's dazzling capabilities have revealed innumerable galaxies, going as far back to a time so old that it challenges how we could unravel the universe's origins. This discovery has ignited an extraordinary evaluation concerning what existed before the Big Bang. One crucial point in time in this mission happened when cosmologist Rohan Naidu, working with data from the telescope, suddenly found a galaxy from just a brief time after the Big Bang, making it the most distant galaxy ever seen. Naidu's discovery sent shockwaves through established experts, highlighting the amazing abilities of the James Webb Telescope. Its gigantic goal to change our viewpoint on the universe has barely begun, promising to reveal astonishing insights into the earliest seasons of the universe's existence. This period, scarcely focused on in the past, holds the key to understanding the development of the first stars and galaxies. The telescope's revelations have clashed with basic theories, uncovering galaxies with characteristics surpassing past presumptions. This phenomenal flood of early galaxies has sparked a storm of scientific inquiry, challenging experts to accommodate these discoveries with existing theories. As scientists find these revelations, they face key questions about the actual nature of the universe and the forces that shaped its development. Beyond the James Webb Telescope's advancements, which are clear, it is seen as 1.5 million kilometers away from Earth, protected from vast interference, and cooled to approach absolute zero by its tennis court-sized sunshield. The telescope coordinates a huge primary mirror and marvelously sensitive instruments, designed to reveal details of the early universe that were previously hidden. This period, known as the Cosmic Dawn, occurred around 200 to 300 million years after the Big Bang, marking the moment when the first stars and galaxies began to form. The process by which this unfolded remains a subject of great inquiry, with theories ranging from the effects of dark matter and dark energy to the interactions between star-forming gas and dust. The telescope's perspective on galaxies from the cosmic dawn presents an extraordinary opportunity for cosmologists to test how they may interpret these complicated components. By studying these ancient galaxies, scientists can either confirm the legitimacy of their current models or uncover gaps in understanding that could lead to major new revelations. From the beginning, the telescope was expected to notice a few weak and small galaxies in its pilot studies. However, reality has far outperformed these expectations. The telescope's initial images of the distant universe uncovered an abundance of galaxies with ages, sizes, and brightness levels that defied all presumption. This astounding surge of early galaxies has sparked a race among space researchers to establish new standard records for the earliest known large galaxies, with new revelations emerging continuously, leaving ordinary experts in wonder. Following the James Webb Telescope's exposures, specialists and observers have raced to study the existence of these surprisingly advanced early galaxies. Some conjectured that errors in the telescope's interpretation of vast observations could be responsible for these surprising discoveries. That said, the consensus remains that these revelations represent a shift in how we could interpret the early universe. The universe and the deal invigorating impression give insight into the potential for immense advancement. The new disclosures from the James Webb Space Telescope about systems have raised significant inquiries concerning the nature of the universe and challenged the suppositions of standard cosmological models. While a few specialists are looking at whether these bits of knowledge can be obliged with existing speculations, Others propose that they may be the main signs that the universe is significantly more intricate and secretive than previously imagined. The critical inquiry in play is our major comprehension of how the universe we know emerged out of early-stage mayhem. The early revelations of the JWST could reshape our fundamental thoughts of vast history, uncovering insights not just on far-off worlds and antiquated structures, but also on the actual nature of our own Milky Way. As Mark McFan, Senior Analyst for Science and Investigation at the European Space Office, puts it, "You build these machines not to confirm theory, but to break it. You just have no idea how it will break." The beginnings of the JWST can be traced back to the Space Telescope Science Institute, STSCI, in 1985, even before the Hubble Space Telescope was launched. Around that time, Jig Weir, then head of STSCI, was tasked with imagining what could come after Hubble. Despite initial doubts, Weir and a small group began laying the foundation for what would ultimately become the James Webb Space Telescope. Unlike Hubble, which fundamentally captures visible light, the JWST was intended to see in the infrared range, allowing it to peer much deeper into the universe. This ability is significant for studying far-off galaxies, whose light has been stretched into the infrared due to the expansion of the universe, making them imperceptible to telescopes like Hubble. With its gigantic cold star-like mirror, the JWST became the chief instrument for revealing the mysteries of the grandiose first light. The need for the JWST was highlighted in 1995, when the Hubble Deep Field Observation uncovered countless galaxies in what was once considered a void patch of sky. This discovery demonstrated the lavishness of the early universe and highlighted the requirement for a telescope capable of probing much deeper into cosmic history. Following 20 exhausting years of development and an expense of around $1 billion, the JWST was finally launched on December 25, 2021. By July 2022, it was ready to begin its most critical year of scientific observations. Early efforts, like the Early Release Science Program and the General Observing Program, were specifically designed to search for early galaxies. While initial expectations were modest, the results far surpassed them. JWST observations have tested existing models of the early universe, revealing galaxies that challenge conventional cosmological assumptions. These dazzling discoveries highlight the significance of pushing the limits of scientific inquiry and showcase the remarkable capabilities of cutting-edge technologies like the James Webb Space Telescope. As scientists continue to explore JWST data, they may uncover further insights that challenge and expand our understanding of the universe. When the first data started rolling in from the JWST, cosmologists eagerly anticipated the results. Many had been preparing their data analysis pipelines for this moment for years. Rather than following the traditional peer review process, which typically takes months, scientists decided to share their revelations on preprint servers like AR14, a platform for research papers that have not yet been peer-reviewed. This approach allowed for a new form of peer review to occur through online platforms like Twitter, where established experts could immediately discuss discoveries. Rohan Nada described this process as science by press release, and the ensuing storm of conversation was both intense and surprising. However, there were concerns about the potential downsides of this rapid dissemination of results. Klaus Pontypool, a JWST project specialist at STSCI, warned that while the quick sharing of results facilitated fast dispersal and discussion, there was also the risk of overwhelming the process. The general understanding among most experts is that the theory of how things came to be remains the primary explanation for the early times of the universe. This theory includes the evolution of stars, planets, and life on those planets, including ourselves. Despite its odd name, the Big Bang offers a convincing explanation for what might have happened at the universe's origins. The universe was densely packed into a space smaller than a pinhead, filled with tightly packed particles. From this moment, a tremendous explosion of matter and energy occurred, known as the Big Bang. This event, happening billions of years ago, set the unfolding of cosmic history. However, changes in scientific data have led to developing anomalies with the assumptions of this theory. When NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever built, investigators assessed that its observations would support the theory of the universe's beginning. Unfortunately, after just 1 year in space, The telescope surprised experts with its ability to peer deeply into the universe's past. The James Webb Space Telescope's astonishing capabilities have uncovered galaxies dating back to such ancient times that they challenge our understanding of the universe's beginnings. This discovery has sparked a serious reassessment of what could have existed before the Big Bang.